In 5.1, we're going to be talking about ratios, and the question that you're going to want to keep in mind as we work is how can you represent a relationship between two quantities? And by the end of this section, you should be able to have a pretty good answer to that. One key idea for this section is that a ratio is a comparison of two quantities, and ratios can compare in different ways. They can compare part to part, they can compare part to whole, or they can compare whole to part. And we'll look at different examples throughout this entire chapter of all of those different types of comparisons. There are at least 3 different ways that you can write a ratio correctly. So if we were trying to do a comparison here, and they ask us to compare 2 blue circles to 1 pink circle right here, we can write it in words and it would look like this: 2 to 1, 2 being the word there, T-O. Sometimes you'll see it other ways, like for every 2 blue circles there is 1 pink circle, or 2 blue circles per pink circle. So there are some other phrases we can use in words, but this is one of the most common ones. You can use a symbol, and remember this symbol here is called a colon, and so you could write 2 to 1 as a symbol using the colon, and you would still read it the same as you do up here. So you would read it like this still, the word form. And then a fraction form, which we'll definitely get some experience with in this chapter, is 2 to 1. And again, you would read it the same way as the word form, but you would have to definitely make sure in any of these examples that you keep the order correct. So in this case, we had the 2 blue circles first, and so we had to make sure that the 2 came first in each of these examples, and then the 1 pink circle came second, so that came second in all of our ratios. And all 3 ways down here mean the same thing. They mean that for every 2 blue circles, there is 1 pink circle. In example 1, we're going to be writing ratios, and they give us an example with some coins here, and they say you have these coins that are shown, and they first, for part A, want us to write the ratio of pennies to quarters. So if we look over here, we'd have to take a look, and again, we've got to make sure that we keep them in this order: pennies first, quarters second. So we can kind of count here, and we can see we've got 1, 2, 3, 4, 5, 6 pennies. So that would have to come first. And you can do it in word form, you can do it in symbol form. I'm going to go ahead and use symbol. And then it says compare that to the number of quarters. So we've got 1, 2, 3, 4, 5, 6, 7 quarters. So we put that second. So the ratio of pennies to quarters would be 6 to 7. And that would be your final answer. And notice we didn't do anything with the dimes in here because they didn't ask us to use that in the comparison. So we just stuck with the pennies and the quarters. For part B, they want us to use that same set of coins, but to write the ratio of quarters to dimes. So again, we're going to start with quarters, and we counted last time, but we're just going to make sure 1, 2, 3, 4, 5, 6, 7 quarters, and that's what we came up with last time. So we're going to put the 7 quarters first, and this time I'm going to use the word form, so I'll use the word 2, and then dimes in here we've got 1, 2, 3 dimes, so it's 7 to 3 as our ratio for quarters to dimes. And notice I'm not necessarily putting labels on these. You just have to make sure that they are in that order, and then you'll be able to read it correctly, because we don't always put labels on our ratios, but that's why it's so important that we keep these in the same order. For letter C, it asks us to write the ratio of dimes to the total number of coins. And remember, in our key idea, one of the things we said that you could do for ratios is a part to whole comparison, and this would be a good example of this because we're taking just the part of the number of coins, which are the dimes, and comparing it to the total number or whole number of coins. So we'd already counted dimes, so we can see there are 3 dimes. And again, they have to stay in order, so dimes came first. And then we're going to compare that to the total number of coins. So when you do the total number, you even have to include the dimes, even though we've already used them over here, because they still want you to do the total number of all the coins. So the number of dimes was just 3, but the number of coins is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And again, in this case, you do include those dimes because that's part of the total number of coins. So in the ratio, it really just depends on what they're asking you to compare. Here are 2 on your own problems. For question number 1, you can see those coin pictures from example 1. Remember, they were all the same, so just pick one of the coin pictures to help answer this question. And then for number 2, you have to interpret the circle graph over here. And when they say use ratio language, they don't necessarily just want you to write the ratio, they want you to try to explain what it means. And if you're a little stuck, then see the answer after you've tried it, and then just make a change if you need to. But at least try it, please, before you check the answer. Any of these 3 ways will work. You only had to pick one of them. And then over here again, doesn't necessarily have to be worded exactly like this, but this would be a good example of using ratio language to explain that circle graph. So if yours doesn't match this, it doesn't necessarily have to be word for word, but it should be somewhat close. And we'll practice different ways that you can use ratio language as the chapter goes on. A tape diagram is another way that we can explore ratios, and it says a tape diagram is a diagram that looks like a segment of tape, and it shows the relationship between 2 quantities. So we're going to take a look at that here in example 2. The question they give us in example 2 is the ratio of your monthly allowance to your friend's monthly allowance is 5 to 3. The monthly allowances total $40. So how much is each allowance? And to help us visualize this problem, we're going to show the ratio 5 to 3 using a tape diagram. And so it's going to look something like this. So you just use the rectangles and you draw the longer one and then you split it into somewhat equal portions. And it says the U, and you can see that it has 5 sections to that tape diagram. And that came from right up here in the problem where it says your monthly allowance. So that one came first, and it said the ratio was 5 to 3. So your amount came first. So you had 5 equal sections of that amount of the allowance. And then it said your friend's monthly allowance was the second number in the ratio. So that would be the 3 down here. So there were 3 equal sections to their part of the allowance. And you can see that altogether there are 8 parts. And the 8 parts technically have to make up a total of $40 because it said the whole amount of the monthly allowances was $40. So we're going to figure out how much each person has of the allowance based on this tape diagram. When you're doing a tape diagram, all the parts have to represent an equal amount. So the total for the allowance in the month was $40. So altogether, this has to represent $40. And there were 8 equal parts that we talked about earlier. 5 for you, 3 for your friend. So you can take the total amount of the allowance, which is $40, divide it by the 8 equal parts, and that would mean that each part of this tape diagram would be representing $5. 5, 10, 15, 20, 25. And so that would mean you earn $25 in the month, and then your friend earns $15 if you were to go ahead and just think about that each one is an equal representation. So you could write it in there, or you can just kind of think about that. So this would equal $25 for you, and this would equal $15 for your friend. So the final answer to the question is your monthly allowance is $25 and your friend's monthly allowance is $15.